Okay, so as promised, we're going to talk about how to name alkanes. And so naming alkanes or the nomenclature of alkanes is going to mostly go by the IUPAC system. We talked previously about there being such thing as common names, right? But most of the naming that we're going to do is going to obey the IUPAC system. And this is for, I think, the International Union of Pure and Applied Chemistry. I think it's been a long time since I cared about that. So IUPAC system, and it's a systematic naming. It's a systematic way to do it, and that means that we learn a couple rules, we follow the rules, and the names just come tumbling out of our mouths. It's really, really nice. The rules, however, are going to take some practice. So let's look at this. The IUPAC name for alkanes includes the parent name, that is the longest carbon chain, the name of the substituents, that is the things that are bonded to it, okay? Substituents are the substitution things on there, okay? And then the names of the substituents and the location of the substituents. And that's it for alkanes, all right? We're going to use what we learned in this chapter for alkenes and for alkynes and alkyl halides and alcohols and everything else, right? So let's get used to these three steps right away. So first of all, let's talk about the parent name. The parent name is going to be the longest continuous carbon chain. The longest continuous carbon chain. So you might be tempted when you look at a structure like this will certainly show up on a quiz or exam, right? You might go, oh, well, that must be the parent chain because it's drawn across the paper. Or this must be the parent chain, right? Because it's sort of central, right? And if that's the parent chain, then maybe this is a substituent and that's a substituent. But I will tell you what's okay. Maybe this is a substituent, and here's another substituent. We've got two substituents, and the pink is the longest continuous carbon chain. But it's not the longest, right? You can see that by looking at it. So it turns out what we're going to have to do sometimes is we're going to have to use a little creativity. When I'm doing this, I am simply going to go through and start counting stuff. So I see, suppose I thought that this was my longest continuous carbon chain. I'd go 1, 2, 3, 4, 5, and 6, right? And I go, okay, so it must be a hexa something, right? And I go, wait a second, maybe if I take another turn, I can get something longer. So I'm going to change my color so I don't get confused. That's still 4, but let's say this is 5, 6, 7, 8, 9. Oh, 9 is definitely longer than 6. So there's my longest continuous carbon chain, right? And can you see that I've got a substituent here? There's a substituent. Here's another substituent, right? Here's another substituent, right? These guys are substituted on the longest continuous carbon chain. So it's looking like I have 4 substituents on there. This is magic, right? By the way, do not do this in your head. If you do this in your head, you will get sideways because the test writer, who is the one speaking at this moment, is going to think, all right, we've got to be able to find students who can fight their way out of a paper bag, right? That was my son is sitting here and he looked at me like, Dad, that wasn't very nice. It wasn't a very nice thing to say. You're right. So we need clever, right? We've got to build a clever apparatus that is robust, something that's going to help us get through difficult times. So we need to have tricky problems that seem tricky, right? But no one's, of course, hoping that you get it wrong. We just want to identify skill, right? And that's what this is about. So, all right. So this is the longest continuous carbon chain, trying to fight my way out of that statement, but I'm not going to re-record the video. We'll let that one go. All right, so we found you see that you've got to find the longest continuous carbon chain, and I'm going to do it with notes. I'm going to do it by numbering stuff. You see I used 1 through 6 and 1 through 9 here. Let's go over here now and talk more about it, okay? So if there's more than one possible longest continuous carbon chain, then you choose the one with the most substituents added to it. Okay, so it looks like here, let me go back to my numbering here, 1, 2, 3, 4, 5, 6, and 7, right? Or 1, 2, 3, 4, 5, 6, and 7. But here, I've got 2 substituents, and over here, I've got 3 substituents. And so it turns out we're going to be choosing the longest continuous carbon chain with the most substituents to it, right? And can you see how my notes is going to make it easy for me? If I make notes and I'm going to circle stuff, right? Because I can count bubbles, okay? So I'm going to bubble everything like I did just here and go, oh, there's 3, okay? So we find the longest continuous carbon chain with the most substituents added to it. Now, how do we name the longest continuous carbon chain? All right, so if the longest continuous carbon chain only has 1 carbon in it, it's called methane. Can you read this? Can you see this from where? If it only has 1 in it, then it's called methane. If it has 2 in it, it's called ethane. 3 is propane, 4 is butane, 5 is pentane, 6 is hex, hept, octane, nonane, decane. I don't think I've ever seen undecane or dodecane on a quiz or exam that I've written, okay? So, but let me put them here for your interest. I don't think I've ever seen icosane on a test that I have administered or a quiz. I don't want to say that you don't need these, but for what it's worth, I would say you definitely need to memorize these. Okay. I haven't written the quiz for next week yet, but I'd say it's a very good chance that you're going to have like a matching for these on the quiz in the upcoming week. All right. And I might have some like misspelled ones or something like that. That would be a good way to help identify students who really knew those names, right? Okay, and then finally, if we're finding the longest continuous carbon chain, if it's actually bonds back on top of itself, in other words, if it makes a cycle, then we call it cyclo. All right, so cyclopropane, you can see that here, is 3 carbons because that's propane. So cyclopropane is when there's a bond between those 2 carbons, right? Here's butane. Well, cyclobutane is if there's a bond between these 2 carbons, which of course we'd have to turn it around and make a square with it, right? And cyclopentane is when I've got 5 carbons where carbon 1 is bonded with carbon 5. Okay, that's an ugly structure there. You can't mix line bond structures with Lewis structures. If you do that, you're going to get in trouble. And I'll do my best to make at least small penalties for things like that, right? Because it's going to end up confusing if you don't. So here's my Lewis structure for cyclopentane. Here's my line bond structure for cyclopentane. And the first rule, as we've said, is finding the longest continuous carbon chain with the most functional groups on it. And that's all we're going to do for this video.